Welcome back to Tech Garage. Why do we have an upside-down bicycle on this show? What we actually have here is lateral runout that I want to show you. Now, in its simplest form, this is the same type of braking system that we'll find on the Silverado. We've got a rotor that spins. It's in motion, just like on the Silverado. We've got pads that when you apply braking power, create friction to stop that rotor. What I want you to see is the lateral runout, the wobble in this bicycle wheel. When we spin it, you can see how it's tracking untrue to the face of those pads. They can't apply equal energy to the front and the back of the spinning rotor. Therefore, we don't have maximum stopping power, and that is ultimately what we're looking for. If you had this amount of lateral runout on your vehicle, you would definitely have a problem. Now, for more information on how the professionals do it, John's got a special guest.
Now, to implement some of that professionalism that Brian talked about, we brought in an expert. We have Steve Cartwright here from Federal Mogul Motor Parts. Now, you're a garage guru, and I heard all about the Garage Guru program, and I know they're all about professionalism. Brian talked about lateral runout. Can you shed a little light on it?
Be glad to, John. When we have too much lateral runout in a rotor, it can push back on the piston and then send hydraulic action back up to the pedal that the customer might feel. So most manufacturers have no more than a 2 or 3 thousandths runout specification so that that does not happen.
Now you can do this right out in the garage. We took a dial indicator, put a flexible arm on it, come down, attached it to the rotor. We zeroed it out the lowest point. Go ahead and fire it up.
Whoa.
Now this one's bouncing all around. Yeah, we got about 6 thousandths there. We got about 2 options at this point. We can have it turn or we can just replace the rotor. But important, before we have it turn, we have to understand discard thickness. So come on over here and we'll look at that.
All right, let's do.
Now discard thickness, that's stamped somewhere on the rotor, okay? That's gonna be stamped somewhere up in here. You can read the discard thickness, and then you wanna take a micrometer. And when you take a micrometer, you can go in there and measure it.
You're gonna put this right across the face of the rotor and try to find the deepest groove if you have any grooves. So using a micrometer, they have a little clutch in here, so you can't mess up, but you have to know how to read a micrometer. And so they also offer digital calipers now to make the job a lot easier.
That would make it easier. Now the point of that is to have the meat on the rotor so it can dissipate heat. Now Steve, we actually took this off a car, believe it or not. The customer come in, we had a rotor that looks just like this. What do you think about this?
I think somebody got a lot of use out of that bad boy.
No heat dissipation whatsoever, and that's what it's all about. Now, in order for that to happen, we have to have these calipers, and we have a whole array of calipers to show you here. We have a fixed caliper, we have some floating and sliding. It's important. This is a sliding, it moves. The actual floating floats on these pins.
Exactly, John. This pin right here has silicone lubricant on it, and we don't want to use anything but silicone because other chemicals might attack the rubber and cause it to swell. So we don't want to use anything like anti-seize, or I've even heard cases where someone mistook the word silicone for RTV, and you can see all kinds of problems would happen there.
It's like glue.
Exactly.
Now we also have a rear caliper. We'll run into a lot of problems with that. Someone will take it off. It has an integral parking brake. So they run it in with a clamp. Not a good idea.
Right. It's got kind of a corkscrew mechanism inside, requiring a special tool to retract the piston. Otherwise, we could cause damage.
The square cut seal is an important part of the puzzle because it actually pulls the piston back in if we release the brakes.
And it does, and a lot of people don't know why. It's purely for the better gas mileage that we can get from pulling that pad away from that spinning rotor while we're driving down the road.
Steve, I heard about Garage Gurus, and I heard about the great things you guys are doing for this industry. Tell us a little bit about it.
I'd love to. We're a support mechanism for professional automotive technicians, and we want to be able to do everything we can do to help them do the job right the first time. So one of the things we've instituted is 12 training centers all over the country, and this year we're going to be adding several more. They're 2 bay shops. They can handle 16 technicians.
Now what about the actual vans? They can come out to the shops and help some of our commercial shops?
They sure can. We have a fleet of vans that go all over the country. These guys can come in and do lunch and learn sessions, help customers with problems. It's an excellent way for us to go right into their shop.
What about some of our viewers? Now they're just going to go out to the garage and do some of this work. Do you have any resources for them?
We do. We have 2. We have Gurus Online where they can go on and take classes, anywhere from just understanding a system, like an entry-level type class, all the way up to a 30-year veteran.
Wow, we can take that professionalism right out to the garage. You know what, Steve? Thanks for coming. We need to get to work on this brake system.
Well, thank you, John. We appreciate being here.